Hi, so today we're going to look at matrices, and I'm going to basically cover everything that's covered in Edexcel Further Maths for Year 1 matrices stuff. So we've got these topics to go through. First things first, basic idea and matrix addition. So matrix is basically any group of numbers. Some is called an array. You're basically just storing some data in this kind of form here. Can take pretty much any shape as long as it's rectangular. So these are all perfectly valid matrices. Matrix addition and subtraction only work if they're the same size. What you need to do here is just add together each number from the same position. So you'd add these numbers together, then these numbers, and so on and so forth. So this would equal 2, 5, 3, 2. Subtraction the exact same way. You just take away the numbers that are in the same position. So 4 take away 3, 2 take away 5, and 7 take away minus 3. Okay, that's fairly painless. Multiplication, slightly harder. I'll do it for 2x2s and 3x3s. There are some more edge cases I'll cover as well. So the method I like to teach is where you want to take the first matrix and just write it down, and you want to write the second matrix. So basically goes on top of it and to the right. So what we're going to do, we're going to write our answer here. So we're going to make sure you're leaving this square that'll be the right size for us. And we're going to work that out now. What you need to do, you're going to go along this way and down this way at the same time, timesing together pairs of numbers. So first, we're going to do 1 times 3, which is 3. We're then going to do plus 2 times 0, so 3 plus nothing. And that answer will go in this slot here. Again, there's going to be 4 slots for this. And that's all you need to do. So for the next one, what's going to go here, I want to go across this slot, across this row and down this column. So I would do 1 times 2 plus 2 times minus 1. So 2 minus 2, and then I keep going. If I want this box, I need to go along this row and down this column. So nothing times 3 and minus 1 times nothing, that would just be 0. And for the last one, it's along this row and down this column, so 0 times 2 and minus 1 times minus 1. So that can be 1, and then to simplify your answers down, and you're done. So this matrix times this matrix gives you an answer of this matrix over here. Okay. Also need to mention, this can work for matrices different sizes, but not always. So here I've got a 2x3 matrix. This means I have 2 rows and 3 columns. Remember, columns go down, rows go across. Let's try the same method and let's see if it works. So move this matrix down here. I'm going to have this matrix go above it slightly to the right. And we're going to try the same idea. So first, I'm going to go across the top row and down the top column. I'm going to do 4 times 3. And then I'm going to add on 1 times 0. And then I've got 2 times, well, nothing. There's no number to multiply here by. Whenever this happens, this means this multiplication will not work. Okay, so because there's no numbers to multiply by that 2, we just can't multiply the two matrices together. We just say it will not work. Okay. Another example, if I change it slightly, so this is a 3x2 matrix, this time it will work. So here 3x2 means there are 3 rows and 2 columns. And if we adopt the same method, we can see now it is going to work. So if I want to work out what's going to go here, I would do 4 times 3 and nothing times nothing, would give me 12. Work out what goes here, I would do 7 times 2 and 1 times minus 1, which would be 13, and so on and so forth. I can work out all these numbers fairly happily. Okay. The key thing to look out for is if matrices will multiply together, these numbers must be the same. So the last number of the first matrix and the first number of the second. So basically the number of columns here must equal the number of rows for the second matrix. Okay, and then it will multiply together. Okay, that was multiplication. I'll do the same kind of example, but this time for 3 by 3 matrices. We'll go through this again just because it comes with quite a lot. So multiplying these together, it is actually the exact same method. I'd only say too much here. Drag this down, let's times them together, and you work it out the exact same way. You would times these together, plus these together, plus these together. And that will give you what's going to go basically in the top left entry here. So it'll be 4 plus nothing will be 4. And you fill it out as going along. So what would go for the next entry for this one here, it would be 400 times 110. So 4 times 1, nothing times 1, nothing times nothing. So it'll be 4 again. And you basically just keep working it out until the whole matrix is full and then you are done. Okay. Okay, here's some questions to try. That's exercise 1, fairly short, it's not too hard. Hopefully this should be the nice, easy introduction. Okay, give that a pause, give it a go. Okay, let's move on. Next we have the identity matrix. Really straightforward, but a massive key thing is basically the matrix equivalent to the number 1. So if you think about the number 1, you know that anything times 1 will always be that number. So whatever number I pick, if I times it by 1, I'm going to get my original number back. That's what the identity matrix does, but for matrices. So if I pick any 2 by 2 matrix, and if I times it by the identity matrix, which is 1, 0, 0, 1, that will always equal what I started with. Okay, the key to remember is this matrix, this identity matrix, works for different sizes. So here, this was the identity for a 2 by 2 matrix. Okay, and these only work for square matrices, so 2 by 2, 3 by 3, 4 by 4, etc. This is often given the shorthand I2, identity for 2 by 2s. If you want I3, or basically I anything, always remember you've got 1s going down the diagonal, and everything else is going to be 0s. Okay, and you just basically keep adding more 1s down here and more 0s to get a bigger size identity matrix. Okay, on to determinants. We're getting to the slightly harder stuff and slightly more important stuff. So the determinant is basically a measure of how big the matrix is. So I'll explain this really quickly, then show you how it's useful, and then how to calculate it as well. So if I've got the matrix 1, 0, 0, 1, you can think of it as how big this shape is. So you basically have this coordinate, which is over here, this coordinate over here, and then the fourth coordinate of that, okay, and then 0, 0, and the fourth coordinate of them two added together. Okay, so 1, 0 plus 0, 1 is 1, 1. This square here has an area of 1, which means that the determinant of this matrix would equal 1. Okay, and we use det as a shorthand for determinant. Same thing here. You want the determinant of this matrix, 1, 4, 3, 0. I have the point 1, 4. I have the point 3, 0. I've also got 0, 0, and then these two coordinates added together. That's a typo, that should be 5, 4. And you would work out what the area of this shape is here. Okay. And again, that can do fairly easily. This is just a parallelogram, so it's going to have a size of 5. 12. So the determinant's going to be 12. To work this out, we have a method. If I'm doing it for any matrix, what you need to do is times these two numbers together, and then take away these numbers times together. So you do A times D minus B times C. Okay? And that would work out the determinant for you. We have a couple of special cases. So if I work out this determinant using the same method, that's going to be this times this, so 4 times 5 minus the other diagonal, minus 10 times 2. And that comes out as 0, because it's 20 minus 20. Determinant of 0 is really key and comes up loads. From the graphical point of view, it means that all these points are on the same line, because the area is 0. We have a special name for this. This is called singular. So a matrix is singular if the determinant is 0. Questions like this come up really often. So here we are asked what value of A would make this matrix singular. So let's work it out. Work out the determinant of this is going to be AD minus BC. So AD is 6 times 4, minus BC is going to be A times 3, and we want that to equal 0, because the matrix is singular, which means the determinant is 0. Simplifying that down, we've now got 24 minus 3A equals 0, which means 3A must be 24, so therefore A is 8. And again, we take it really quickly. 6 times 4 is 24, 3 times 8 is 24. So it does work. So here, this matrix with A being 8 would be singular, which is really important that I'll come on to in a second. Slightly harder. We can also determinant of 3 by 3 matrices, although it does get slightly more involved. Okay, I'll go through this method. So first step, you can pick any row or any column to work it out from. The advice always is try and pick the row or column with the most zeros. Okay, here I've got a couple of options. I'm going to go along this row here because I've got the 0 here, which makes my life a bit easier. What we're going to do, we are going to pick a number. We're then going to cross off that row in that column, and we're then going to times it by the determinant of what's left. Okay, so the determinant of A, first I'm going to do 2 times, and then it'll be the determinant of 4102. And if I ever use these straight line brackets, that's like shorthand for saying determinant. So don't write det like 3 times for this. Okay, that's the first step. We then need to keep going. You notice in the top right, I've drawn this little matrix here. This basically tells us what sign these numbers are going to take. So for example, here I used this 2. This 2 is on a positive sign, so it stays as positive. Moving on, I now need to expand across this 1. Because this is with a minus sign, I have minus 1 times. Okay, and it'll be minus 1 times. I take out the row in the column, and it's times by the determinant of what's left. So minus 1, 1, 5, 2. So I've just squished these 2 and these 2 together. We then have one more. If I look back to my little guide here, I'm on this 0, so it's a plus. And then it's going to be plus 0 times by, well, whatever. We know anything times by 0 is 0, so it really doesn't matter. I'll do it anyway. Cross this, it'll be plus 0 times the determinant of minus 1, 4, 5, 0. And then we just work it all out. So 2 times AD minus BC is 8 minus nothing, so it's 8. It's then minus 1 times determinant of this, so minus 2 minus 5 is times minus 7, and plus 0 times anything is always 0. We can then work these out. I've got 2 times 8 is 16, minus 1 times minus 7 is minus 7, which will give me 23. So this determinant, this matrix here, has a determinant of 23. Okay, if that didn't make sense, do watch it again. It is really important. I'm going to use it again in a couple minutes' time. Okay, last couple of things to cover. Again, they are a bit more involved, but I'll go through them fairly speedily. It will be stuff we have covered up here. So, inverse matrices. First of all, by definition, if I've got some matrix A, so let's just say it's this matrix here, if there's an inverse for it, then it has the property, if I times a matrix by its inverse, I will get the identity matrix. Okay, so in this case, because my A was a 2 by 2 matrix, I would get the 2 by 2 identity matrix, which just to remind you, is this fella here. Okay, so now we can work out how to find the inverse of 2 by 2 matrices. Really straightforward. First things first, you always have to have 1 over the determinant. I'll call this matrix A. So 1 over det A. And then you basically just rearrange this matrix around. What we're going to do is you swap these two numbers around. So it's now dA, and for these two, you just flip the signs around. So it's minus B minus C. And that will be the inverse of a 2 by 2 matrix. Okay? So quick example here. I've got this matrix here. First step, I want its determinant. Let's just call it B. Determinant of B, to work it out, I do 2 times minus 3 minus this. So that could be minus 6 minus nothing, which is minus 6. So therefore the inverse matrix, B to the minus 1, so this was A to the minus 1, is going to be 1 over minus 6 times by this matrix here. So these two swap places. So minus 3, 2. And these two I flip the signs around. So 0, minus 5. Okay. And in case you're clean it up, all I'm going to do right now is just take this minus up here. Just looks a bit nicer. As a rule of thumb, don't take the 1, 6 into there unless it makes it really nice. You're just making more work for yourself, really. Okay. Also worth mentioning, if you have the posh A-level calculators, the really big ones, that can do inverse matrices for you. Look up how to do that. It'll save you tons of time. Okay, so the whole point of that, the whole point of inverse matrices and most of the stuff is so we can solve this kind of problem. Okay. So I have this matrix equation here. If I times these together, this will multiply together to give me 2x plus 1y and 7x plus 4y. So what you've actually got here, this is a matrix way of writing down a simultaneous equation. When it comes to exams or tests, they're going to want you to solve it using matrix inversion. Okay? So what we're going to do, we're going to work out the inverse of this matrix. And I'm going to times both sides by that inverse matrix. What's really important to remember is that it counts which side you multiply it by on. So because on this side, this went at the front, it must be the same over here. I can't have this at the front of the expression and this at the back, because it will give me different answers. Okay, so make sure the matrix you add on, they either both go on the front or both go on the back. They cannot mix and match, or they can't go in the middle at all either. Okay, this will be really useful, because if I times a matrix by its inverse, it gives me the identity matrix. So basically, if these things times together, they're going to, in essence, they're going to kind of vanish. So I'm going to be left with xy equals this inverse matrix times by 3 minus 1. Okay, let's see what we can do here. Let's work out this inverse matrix. So I'll do it the same kind of way I was doing before. I'm first going to find its determinant. That's always your first step, is work out the determinant. 2 times 4 is 8. 7 times 1 is 7. So here the determinant is 1. So the inverse will be 1 over 1. I'll just ignore that. And then do the same trick as before. I swap these two around. So it's 4, 2. And these two both now have minus signs. That's my inverse matrix. And we're pretty much there now. xy, my solution, is going to be this inverse matrix. 4 minus 1 minus 7, 2 times by 3 minus 1. And now let's times these together. So we have 4 minus 1 minus 7, 2. And we have 3 minus 1 over here. Again, the same trick we did right at the start of this video. Going to work out what comes here first. So we need to times along this row and this column. So 4 times 3 is 12. Minus 1 times minus 1 is 1. Add those together gives me 13. Do the same thing here. Minus 7 times 3 is minus 21. 2 times minus 1 is minus 2. Add those together gives me minus 23. So that means xy is 13 minus 23. And again, just to recap, what we've worked out there was the solution to this simultaneous equation. But rather than solve it using normal methods, we can solve it using matrices. This is a really useful skill because the more advanced you go in maths, you basically see bigger and bigger matrices. So if you know how to use this method, it scales up a lot nicer than the current method you've seen where you do substitution or elimination. Okay, one more thing to do. It is the biggie. This is how we inverse a 3x3 matrix. Okay, there's a few steps to this. The idea is we want to solve this kind of equation. Okay, and we'll do the exact same way. We know that x, y, z would be the inverse of this matrix. Again, make sure it goes to the front. Times by 2, 4, minus 1. And if I haven't mentioned it enough, this minus 1 just means inverse. Okay, in the same way you have sine to the minus 1 and cos to the minus 1. Okay, we basically need to do three things. We have to find determinants, we have to transpose a matrix, and remember this plus, minus, plus griddy thing. Okay. So, let's recap find determinants first of all. So this we saw earlier. I think this is the exact same question we had earlier as well. So if I skip up, we know for this matrix the determinant was 23. So here this determinant equals 23. Transpose matrices I'll just talk about. It's basically where you flip it all along its leading diagonal. So here I've got this matrix A. If I transpose it, I'm basically switching around everything. 1 and 4, they're on the mirror line, so they don't move. So I'll go to this matrix where the 3 and the 2 are swapped around. Also works for non-square matrices, but of course we're going to change size as a result. So here the 2 and the minus 1 are swapped around. This 6 goes to here, and this 0 goes to here, and there's nothing to sort of go back to these spaces over here. Okay, let's go for it. So we've got this matrix, we've seen it a couple of times now. We're going to find its inverse. Determinant we have seen was 23. Okay, matrix of minors, that's called M. That is what we found as a determinant. So if I want the matrix of minors for this first entry, I basically cover the row, cover the column, and work out the matrix of what's left. So here, sorry, not the matrix, the determinant of what's left. So here this has a determinant of 8, because it's 8 minus nothing. Next, I'm going to work out what goes here. So minus 1 times 2 is minus 2, and minus 2 minus 5 is minus 7. Work out what goes here. Nothing, minus 20. And I'm going to keep going through all of that. So this is 2, this is 4, this is minus 5. Again, this is a fairly tedious method. 8 minus minus 1 is 9. That was in the wrong place. That is for that square there. Again, this can be created to make mistakes because it's quite tedious. And 2 minus nothing. Okay, that's my matrix of minors. Hopefully without any mistakes. Step 3, we apply the rule of alternating signs. So we had this old plus minus plus griddy thing. And basically anything with a minus sign on, we're going to flip its sign around. So now I've got the matrix 8, 7. And basically these 4 are going to swap signs. And everything else stays the same. Step 4, I need to transpose the matrix. Again, this is where we're basically going to flip it along this diagonal here. So the 3 numbers on the mirror line are not going to change. They're going to stay as 8, 4 and 9. These 2 swap around, so it's now 7 and minus 2. These 2 swap around, so it's now minus 2 and 5. And these 2 swap around, so it's minus 20 and 1. And then we're pretty much done. Step 5, write down the inverse. The inverse, if to call this A, that will be 1 over the determinant. And the determinant we worked out at the start was 23. Times by this matrix here. Okay, so a lot of steps in doing this. Something worth practicing. So again, like I said earlier, you can use a calculator to do this, but they're kind of wise to that, and like asking lots of questions where you have to do it without a calculator. Okay, so we could use this to solve this equation. And is that the same matrix? Yeah, so same matrix we've always used. So we know the inverse matrix is this thing here. So x, y, z will be this inverse, or this inverted I should say, times by minus 2, 4, 1. You would work out the inverse matrix, which we've just done, and then you would times that by minus 2, 4, 1. I won't go through that, but yeah, you're absolutely fine doing that. It's the same method as before. You would have this matrix here, and then you would have the other matrix on top of it, and then go along rows and go down this column. Okay. Also, piece of advice, only leave the 1 over 23 outside the whole vector matrix you get as an answer. So your answer will be 1 over 23, and then whatever you get from this. Okay, don't bother taking it in, it just makes more work for yourself. Okay, you have some questions to try. Same idea. Keep in mind for most equations you can solve using the calculator. As I said before, they're wise to this, so often they throw in bits of algebra, which then makes it pretty much impossible to use a calculator. Okay, for those questions, hope that was a useful recap to you, and good luck. Okay, thanks for listening.